Hi, how's it going? As we start developing our projects, we might run into a bit of a pickle in developing our enemy behavior, or really any sort of decision behavior, whether it's our friends, our enemies in the game. A lot of times, in my case, this turns into a big, horrible, like nested while loop. So here's something we can use instead. Basically, finite state machines. Now, the way a finite state machine works is we have some input of some kind, and we have a transition logic, transition decision of some type, and that tells our machine what its next state should be, and that is kind of remembered in a set of variables representing the state. And we can also get the present state and feed that through. There might be some process, some extra processing on that, and it comes out as output. But really critically, we can also take that present state and feed it in as another input. So a finite state machine has a state, and its next state is determined by some input from the world around it and its present state. Okay, so what this comes down to is essentially something like next state is determined by some function which takes some input of some sort, like that. And really, because we're taking this as our next state and then we're storing it in, our variable, then really our update is more like this, right? So we have the input from the world around us that we're sensing and what state we're in right now, run that through a transition function and return that, store it as a current state so the machine can update itself. Well, today is going to be more theory than practice, but I'll run through an example of how we could implement this for a basic enemy. Let's say we have an enemy and we want to, as our input, take the player position and the environment. For instance, like walls and stuff, we might want to know where that is. The first step that we do is we kind of write down all the states that we want our enemy to have. So we might want the enemy to have a wander around state, a choose direction state, and then we get near the enemy, get near the player, we might want to start aiming at the player, so turn around so we're facing towards the player. Want to shoot the player. If the player shoots us, then we get staggered, so we get hurt for a bit. Player hurt animation or something, so it kind of pauses the enemy a little bit, can't do anything, and then we might also die. Okay, so there's a bunch of states. Now what we'll do is to draw this out in a state diagram, we put a circle around each state, and the top of the circle is the name of the state, and the bottom half of the circle is at least a basic description of what we're doing. Okay, so if we die, I don't know, be dead. Or play the death animation and then pause in the final frame or something. You know what I mean? Animation, okay. So when we get hurt, we'll have maybe an animation of the model like staggering back for a frame or two. We'll let that play and then we'll reset into the next state. When we're aiming, then every frame we want to turn towards the player. When we're wandering, then we've already picked a direction, so we're going to walk forwards. Okay. When we're shooting, then we'll have some sort of shoot routine or something. So that'll be an animation of the enemy shooting, and then maybe setting an internal flag to say, hey, we want to produce a bullet, or we're ready to shoot, basically, and then reload or something. And then to choose direction, we take direction, set that to random. Okay, so then we'll look at the transitions. So I guess if I was making a really simple enemy, the first thing I do is I'd always start them in the choose direction state. And let's actually go ahead and label these states. These numbers here are kind of, if I was storing the state in a variable as an integer, then we could use those as the values like an enum sort of thing. That's something we could test pretty easily. So once if our current state is choose direction, then in our behavior, in our output logic, we choose a random direction, and then we transition into the wander state. Okay, so there's no condition there. We just choose a random direction and go straight away. Okay, now what about going from wandering to choosing a direction? I guess we could say do that if we've hit a wall. Or maybe if we've walked a certain distance or something, we could do that as well. Okay, so of course, if we wander and we get close enough to the player, we want to shoot the player, but first we want to aim around, like spin around and face towards them. So we'll say we'll do this if we're near to player, and then to simplify this, let's say, okay, we'll try to aim and shoot, and then if we've shot and then the enemy is far away, then we will then we'll spin around and walk, basically. Okay, so aiming. Well, we transition from aiming to shooting when we are facing the player. Okay, and then what are we going to do? Well, if we're far from the player, then we'll just start walking. If we've shot and we're still near the player, then let's aim again, because the player could be like circle strafing around us, so we might want to shoot once and then readjust and then shoot again. Okay, now dying, well, that happens if our health is less than or equal to 0. Okay, getting hurt. Well, if we've gotten hurt and then our health is bigger than 0, well, clearly we're in a combat situation. Okay, so I'm not going to make zombie enemies that get shot and then just keep walking. No, if we get shot, clearly we're close enough to shoot back. So this is, if our health is bigger than 0, if we're still alive, then shoot. Right, and of course, any transition, this is going to mess up my diagram, right? But any case where we get shot, then we go immediately to this state. Okay, and clearly all of these are if we got shot. It's for all those arrows there. Now, how we determine that is up to us. We could, when the player gets shot, set a binary flag or a variable within their, sorry, I said player, I mean enemy, within their fields, or we could keep track of the health, and then if each frame of health is reduced since the last frame, then, yep, do the hurt animation thing. But I prefer the former, because if it's the scene object setting this automatically, setting this flag that we've been hurt, then we can also set other information like which object hit the player to cause that, and which enemy or player did that. So then the enemy gets a target that they can aim and shoot at. Anyway, so this is a little bit of a mess, but as you know, the difference between a spaghetti code and a well-designed product is something which is planned out ahead of time. I would encourage you to, if in your own projects, try to develop a basic diagram and structure, and try to vary it a little bit as well. So one example is, let's say we take not just the player position, but a bunch of fellow enemies, and the enemies say, okay, there's a player here, there's another enemy, and their state is that they're shooting at that player. So I am going to try circle around to be behind the player to make it challenging for them. And then if we have like a whole bunch of enemies, they could do a calculation and say, okay, what is the maximum sort of dispersal that we can set up to encircle the player? So we have emergent complexity as the situation gets rougher. We could even do things like add a heuristic function. So we're not just following a fixed sort of this, then this, then this. We are deciding each frame, what should we do based on a sort of utility function, like how valuable is it for me to be shooting right now? How valuable is it for me to be wandering around and things? That might be a little bit of overkill, but it is fun to think about. So, just another little bit about how we could kind of start implementing this. So, what we'll do is we'll have our update function. For example, in Python, we take as a class function, of course, within the player, within the enemy. Yes, this is some sort of description of our environment, the geometry that we're walking around in or something. So what we do is we say self.state equals. Okay, so we call our transition function. With our input variables, and our state is already kind of in the class. And then we will say, you know, if state is equal to 0, which was, I think, the random direction thing, then do something. Do something else, and so on and so on. And the something that we've got here is described in our state diagram on the bottom half of the circle, right? That's kind of a basic description of the behavior that we want to do. Okay, so that is the kind of output logic, and that is handled in the update. Okay, then we'll have transition. Yada, 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 the same signature. So what we'll have is, we'll say if state is equal to 0, then, well, we're in state 0. Just thinking. So we do want to handle something. Okay, so let's say we also have initial conditions, right? So when we create the enemy, then we set their direction to random, and then we put them in state 0. So we're pretending that they've already chosen a direction, okay? So if state is state 0, we'll pretend that we've, because if we transition to state 0 from another place, then we'll handle it here, choose a new direction, anyway. Okay, so again, if we're in state 0, then we'll immediately transition to state 1. Now, if we're in state 1, what are we doing? Okay, we're going to have some sort of test to see if we hit a wall, or if we're near to the player, or if we got shot. So we'll say so we'll have some sort of test which takes the environment into account. If we've hit the wall, return 0, because we need to choose a new direction. We don't really need elif, do we? Because return's going to jump us out of there. But anyway, otherwise, if we're near to player position, which was passed in as an input, then return, I think that was 2. 3. So 3 for shoot, 4 for hurt. Return 3 for shoot. Something like that. So what we've done is we've broken this into one point where we choose what state we're going to transition to, if at all, and then another point where we handle what we're doing there. So again, we go here, we go direction equals random I'm being a little bit sloppy here with my my pseudocode, but there we have it. Hopefully that's interesting. I think it's a good way to impose some structure on programs so that they don't grow to insane proportions. I hope you had fun, and I'll see you in the next one. Bye.